Kirk Math. Hooray! Welcome to 10.1 Dilations. We've made it. We're now going to learn how to take a shape and change its size, but not necessarily move it around. All right, so we're going to dilate a figure given a scale factor and write an algebraic expression about the dilation. All right, lots of notes. Since we have this new word of dilation, we need to write down a lot of information about it, okay? So a dilation is the change in size, but not shape of a figure, okay? We're going to stretch or shrink this shape or enlarge or reduce, okay? Enlarging or stretching is making it bigger. Shrinking or reducing is making it smaller. Now, this shape this shape or figure is going to be the exact same shape or figure. We're not going to make it look funny. We're just going to make it the same proportions as it was before, but bigger or smaller. Okay? A lovely example of a dilation would be like when you have an image on a computer, I can grow or stretch or shrink this image, and the image stays the same. My little cow here still looks like a little cow, okay? But if I wasn't doing that, if I was not keeping the proportions, then I would be elongating the image or widening the image. And here, this image does not look like my original cow, okay? If I'm doing this, then I'm changing the dimensions of my image, and it is not congruent to the original image or even the same shape, okay? With a dilation, our image is the same as the original one. It's just changing size. It's still the same image. Okay. So a center of dilation is a fixed point where the lines connect the figures that intersect. So basically, if I were to draw a line between the smaller image and the bigger image, and I would draw another line, wherever the two lines intersect, that's where the line was growing from. Okay, that's the point of dilation. That's where it's growing, either enlarging or reducing from. Okay, sometimes it's in the middle and it makes it bigger and smaller from the middle. Sometimes we go outwards or inwards. It just kind of depends on where we want the center of dilation for our figure. Like we said, dilations, the figure's not congruent. It's not the same size as the previous image, but it does have the same orientation and it has the same proportions. When we dilate a figure, we use something called a scale factor. A scale factor tells how much a figure is enlarged or reduced. Am I making it twice as large or half of its size? The way that we look at a scale factor is we take the new image divided by the original image, and that gives me a number that tells me the scale factor. Or its image, the new one, compared to its divided by its pre-image, the original. Scale factors that are greater than 1 enlarge our figures, and scale images that are less than 1 reduce our figure. And the way that we're going to do all these dilations algebraically and mathematically is through multiplication. If I tell you that a shape is 2 times as large, then I'm going to multiply the x and y of my shape by 2. If I say my shape is half as large, then I'm going to multiply my x and y by 1/2. N is the scale factor. Okay, so let's actually do this. Let's actually dilate a figure. So here we're going to dilate by a scale factor of 1/4. Because this is less than 0, we are going to shrink or reduce our image. We're going to make it smaller. Okay? The first thing I need to do is identify the points of my shape. So if this is point 1, 2, and 3, 1, 2, and 3, we need to write down its coordinates on the coordinate. Okay, so I have my values here from my points 1, 2, and 3. And what I'm going to do is just multiply both x and y of my pre-image by 1/4. So I have -4 times 1/4 and 4 times 1/4. 0 times 1/4 and 4 times 1/4. And then again, -4 times 1/4 and 0 times 1/4. When you multiply, remember, when you multiply fractions, you put your whole number over 1 and you just multiply straight across. 4 times 1 is 4. 1 times 4 is 4. 4 divided by 4 is 1. So that's how we're getting some of these answers here. So when I reduce -4 by a fourth, I get -1, and 4 times a fourth is 1. And then here I have the same thing here. So once I'm done multiplying, I have my new shrunk image, my itty bitty triangle right here. I graphed my points, and this is now my image, shrunk by a fourth of the size. Okay, so on this next image, we're actually going to grow or enlarge our shape by multiplying it by a number that's greater than 1 by a factor of 3. So I have my coordinates here for A, B, and C, and I went ahead and went times 3 on each one. So I'm going to take every X and every Y and multiply it by 3. So my new coordinates for this shape should be 1 times 3 is 3, 1 times 3 is 3. 3 times 3 is 9, 1 times 3 is 3. 1 times 3 is 1, 3 times 3 is 9. Or sorry, 1 times 3 is 3. All right, these should be my new coordinates, and let's go ahead and draw this bigger triangle. So 3, 3 here, 9, 3 here, 3, 9 here. And if I connect these carefully, I now have my larger image. So this is A prime, B prime, and C prime. You can see that my shape is in the same position. It is the same overall shape of a right triangle, but it is not congruent. It is larger than my previous shape. Now on this image, we're actually going to have to do the opposite, okay? I have 2 images, and I need to figure out what is the scale factor. What am I multiplying my original image by to get my new image, okay? Remember that a scale factor is the new image divided by the original image, or the image prime divided by the pre-image, not prime, okay? So we're going to take a look at the values. Obviously, our image, pre-image is the blue here, and our image, or prime, is here. And we're looking at how the values of X and Y change, okay? So let's write that. So just by looking at these numbers, you can probably tell that to go from D to D prime, I have 4 to 2 and 10 to 5. I can already tell that these are a difference of 2, right? 5 times 2 is 10, or 10 divided by 2 is 5. The new image, prime, is half of my previous image, but let's prove it mathematically. So if I take all of my numbers and I do my image, 5 divided by, let's go X first. 2 divided by 4 and 5 divided by 10, both of those can be reduced to 1/2, okay? 5 over 10 is, and 5 over 10 are also 1/2. 2 over 4 and 3 over 6 is also 1/2. And 5 over 10 and 3 over 6 is also 1/2. So all of these, just to show you where I'm getting my information from. So my 10 here, and then my 5 is coming from here. So I'm taking my image here, and I am putting it over my pre-image and dividing. And what I'm going to get is my scale factor, which is 1/2. Because all of those fractions up here can be reduced to 1 over 2, 1 over 2, 1 over 2, 1 over 2. So that's it. Here's another one where you are trying to figure out, how do I get from my pre-image, which is the blue one, to my image, which is the green one. Now, obviously, we're growing, so we know we're going to be multiplying by a number greater than 1. But what number is that? So again, we're looking at the coordinates of our pre-image, And then you need to write down the image coordinates of your image and try to find the ratio here. So remember, you're going to do basically A prime over A, B prime over B. You need to divide them and see what is that going to get you. That's going to be your scale factor. So take a moment, pause the video, solve this, and come back to see if you're right. Okay, you should have gotten a scale factor of 3. All of my pre-image values, if times by 3, create my image values. And you can also tell because if I am here at 1 times 3 will get me that much larger. Okay, so the green square is 3 times larger than the blue square. All right, our last problem here, you need to be able to dilate the following figure by a scale factor of 1/3. So that is less than 1, so we're making a smaller triangle. And write the algebraic expression to describe the dilation. So I need you to write for me, if I am reducing this by 1/3, okay, I'm going to have x and y in here. What do I need to do algebraically to show that my new triangle will be reduced by 1/3? And then actually reduce this by 1/3. Pause the video, come back and see if you got it right. All right, the algebraic expression to describe the dilation is 1/3 x, 1/3 y. So I went ahead and multiplied all of my values by 1/3. Here are my new points. Oh. Sorry. And here's my new shape, 1/3 the size of the original triangle. All right, good luck.